Numbers are an important part of any program, and JavaScript makes it really easy to work with numbers. In this video, we'll see how to define our numbers in our JavaScript programs. So now we'll be learning about numbers in JavaScript. I have the basic HTML and JavaScript page set up that we've been using in the previous videos set up right now. So we have an index.html file, and at the bottom we have a script with the source of numbers.js. This numbers.js file is where we will be experimenting with numbers in JavaScript. Now we've seen the basic usage of numbers in JavaScript before while we learned Introduction to Programming and in some of our earlier videos. So what we're going to do now is take a more in-depth look at JavaScript numbers and the different ways we can create them and manipulate them. So let's take a look at the different ways we can create numbers. The basic way of creating a JavaScript number is typing in decimal numbers 0 through 9 to represent your number. So let's store a number in a variable called a, and let's just make the number 11. This is the simplest way we can create a number in JavaScript. We simply type in the number 11, and that number is now stored in our variable. We could create a negative number by simply prepending a minus sign to the beginning of our number, and then typing in our digits as usual. So negative 123 can be represented by minus 123. And if we save it out and go to our page, we can refresh it and we can inspect the different numbers. For instance, A was the number 11 and B was the number negative 123. That's pretty easy. So what we see now is an example of whole numbers. Now we can also use the decimal point to create numbers of arbitrary precision past the decimal point. So let's create variable C. And if we wanted to represent the number 1.5, the way we would do that is by typing 1, period, 5. And we can add more numbers to that. For instance, we can make D equal 123.456 or 789. So if we go back to our page and we check out the numbers C and D, we have the numbers 1.5 and 123.456789. Now there's a very important detail when considering these floating point numbers versus these whole numbers. In some languages, when we represent a whole number or represent a number with a decimal place, they're actually represented by different types of numbers. For instance, in some languages, a whole number would be considered an integer or an int, and a number with a decimal point would be a floating point number, meaning it has some arbitrary precision past the decimal point. But in JavaScript, however, there's only one type of number. So even though the number 11 looks like it's only a whole number, it's really 11.0. Now this has some implications because in some languages, when you, for instance, divide two whole numbers or integers, the answer, because both of the operands were integers, would also be an integer, perhaps rounded down. However, in JavaScript, no matter what, since they're all one type of number, we'll get these floating point type numbers anytime we do an operation. So because all numbers in JavaScript are floating point, there is a specific type of perhaps error that you would have to watch out for when doing mathematical operations on our numbers. So let's take an example. We'll create a variable called e, which is 0.1. We'll create a variable called f, which is 0.2. So if we create a variable called result, and we'll set its value to e times f. The asterisk here is the multiplication operator, so we're multiplying 0.1 by 0.2. Now, we would expect the answer to be 0.02. However, if we check it out in the browser, when we refresh the page, and we see what is stored in result, we'll see we get something very near to 0.2, but it's actually 0.02. 0, 0, 0, 0, so on and so forth, and then a 4 at the end. And this is a rounding error. And this is a result of how numbers are stored on the computer. Because each number has a very limited amount of space to store its representation on the computer, and there's an infinite amount of numbers that could be represented using this decimal notation, some rounding has to occur. And usually you can see this when you multiply numbers like 0.1 and 0.2 together, where you get a number that's very near the result you want, but not quite the result. Usually this doesn't happen when multiplying or dividing whole numbers because the way the number is stored in the computer is better able to represent the results. So for instance, 2 times 3 would equal 6. So you don't really have to worry about whole numbers. Now there are various ways that if this does become a problem in your program that you can get around it, either by manually rounding your results, or for instance, if you're dealing with money and you use dollars and cents by saying $10.50 would be represented by 10.5. To avoid these errors, what you could do is represent money, for instance, in cents. So instead of $10.50 being represented by 10.5, it would be 1,050 cents. That way, multiplication and division operations wouldn't be affected by the fact that your cents are represented to the right-hand side of the decimal point. So we've seen how to create whole numbers and floating point numbers in JavaScript, as well as how to use the negative operator to create negative numbers. In the next video, we'll see a couple other ways to create numbers in JavaScript. So far, we've seen some basic ways of defining numbers in our JavaScript program, but there are a few more advanced ways that we can define our numbers. In the next video, we'll see what those are.